All right, good afternoon, everyone. So it's always tough going on the last presentation on the third day. I'm not sure what I did wrong here to get this slot, but Jason and I will talk about that after. So I actually thought about doing a little joke here, and I was going to put a slide deck up there and get the folks at Zerto a little bit nervous and put all of the things that we thought were wrong with the product and do that just to get everybody awake. But didn't feel the need to do that, and actually the relationship that we have with Zerto is absolutely phenomenal. So you'll see that throughout, resonate throughout the rest of the slide deck. So my name's Scott Hinault. I'm Senior Director for Architecture and Infrastructure at Kronos. I've been with Kronos for almost 2.5 years now. Matt Braga, I'll let him introduce himself when he gets up to do his slide. So I'm just going to walk through a couple of things here. So the biggest thing I think that we want to get across here, and Matt's going to go into a lot of technical detail. This is actually his presentation. He was kind enough to let me be a part of it and just open it. But to talk about this and how we use this at scale, it's significant here, and so you'll see that go throughout the entire slide. So I'm hoping that that is something that you folks find valuable. So in that vein, let me just ask, it's a smaller group here, but let me just ask, how many of you are existing Zerto customers and already implementing? Okay, so maybe about half. And then the other half, are you in the process of evaluating Zerto as a product, or are you are? So how many of you are evaluating the product? All right, good. So then I think it's healthy for both. I think it'll be a good presentation because I think we'll be able to talk to both of that. So I'll spend a little time on one of the slides talking about the prospects here. That are looking at Zerto for potential purchase. So the agenda, I'll talk a little bit about who Kronos is. We had a clear business case, and we needed a very clear and solid and stable solution, and there really wasn't one when we thought, at least going through that process, so I'll talk about that. Then Matt will get into our journey. Basically, he tried to do the analogy, which I think is great, from driving flatbed trucks to driving Ferraris, which is where we are now with Zerto. He's going to talk about the infrastructure highways, and he thinks about that from a throughput perspective, how we onboard those workloads and the thousands of VMs that we're onboarding, and then we'll talk about how some of our goals and our objectives and what we've seen so far from an RPO and RTO perspective. So a little bit about Kronos. We're a $1 billion global workforce solutions company. We have 30,000 organizations across the globe that are using the solution. Those people employ about 40 million employees. And we are in more than 100 companies. So we're a large company. So if you think about Kronos, I think we're actually celebrating this year our 40th anniversary. Very, very strong people culture within the company. If you've seen any of the press around us, we, year over year, best place to work sort of culture. The CEO, Aaron Ains, very involved in driving that culture with the employees, working directly with employees. And from a product perspective, we're in the human capital management space. So what that means is we develop solutions and products for performance management, recruiting, compensation management. The company was really born and founded 40 years ago on time and attendance, and that's still its core product today. So you go to healthcare, you go to manufacturing firms, people are taking a card and they're swiping their card. That's typically a Kronos clock. We are the marquee #1 company in that space. And then we're collecting all of that data, and then we're putting that through the interfaces back to large enterprises from a payroll perspective. So it's critical in what we do. So one of the things we try to talk about, at least from our perspective, is you think about the person out in the Midwest carrying a lunch pail. They could potentially be living paycheck to paycheck. We have the ability to affect that positively or negatively. So we take that very seriously. So 7 years ago, just like everyone else probably in the room is experiencing something similar to this, whether you're even in your own IT shop going to a public cloud, or you're taking a company like Kronos who developed on-premise software applications for the HCM and time and attendance industry and had to figure out how do we morph that to stay competitive. Customers start coming, they hear about the cloud, they want to deploy in the cloud, and so Kronos started that journey. Massive transformation across the company, not only from a technical perspective, but from a culture perspective. So in the context of what we're talking about here, it's about the Kronos cloud. So we built our own private cloud 7 years ago, architected that, built that out, built that at scale. You know, somewhere along the line, I would say, 3 or 4 years into that, timing is everything. I joined when the company the growth rate was just exponential. It's so, people like myself and Matt are working every day to try to keep up with that growth, trying to scale with that growth, trying to mature all of our capabilities as a private cloud provider. And so when you think about that in the context of what we're doing from a DR maturity perspective, this is where Zerto came into play here for us. So clear business case, so I just alluded to it a little bit. So again, when you think about it from a private cloud perspective and a 7-year growth and all of a sudden hitting that growth rate in the business model now has proven itself, the company's willing to start to invest and put the dollars, capital and otherwise and OpEx behind that. So, so we're looking across maturing that in everywhere, across our tool sets as far as what we do to manage that. And then we were looking at that from a disaster recovery perspective. So we started looking out in the industry at who are those providers and that can do that. And some of them, I'm not going to mention the names, but some of them are very well known. And then there was this company that sort of fell into the box for us where we wanted to take a look at, and that was Zerto. So we typically push very, very hard on our partners and literally use that term because that's what we believe in and that's how we manage within our own space. I have a very strong philosophy that says my partners aren't my vendors because I can't do my job without them, so they literally are our partners. They have to be just as critical as the employees, and their execution and performance has to be at that exact same level that we strive within our own organization. Otherwise, it just flat out doesn't work. So you take a look at Zerto and a new company coming on board, new in the industry, starting to get some traction there. So honestly, we were a little hesitant in that space. So we worked very closely to make sure that we tested that out. We went through an extensive proof of concept with multiple vendors. One of them we were sort of using on the side already, so we knew a little bit about them. We didn't know anything about the Zerto product other than what the marketing material would say about looking at the product just works, its ease of use, implementation, all of that was there. But then we looked at it from a Kronos private cloud perspective and said, this is a massive scale and we're going to push them beyond at least what we believed anyway. They may have already known that they could meet that, but from our perspective, we thought we're going to push them beyond what we think they've even experienced, and it's going to be in production, a live, private cloud environment, and how is that product going to behave there? And it has to behave flawlessly. It can't impact any of the I/O in the environment. It can't do any of that, right? So we certainly pushed and worked with them, and they were phenomenal. So looking for an enterprise class, everybody use that term, but it's true, must scale with the business growth because we were growing exponentially at over triple digits per year. So we keep adding that infrastructure into private cloud, and we needed to make sure that the product could scale and move with us. So and we were looking to improve in a predictable recovery solution, automate onboarding of the workloads to the product, which Matt will talk more about, and then solution to eliminate or effectively minimize source workload contention within our environment. Again, can't affect anything within our environment. It has to be something that sits outside, but is still able to transition the workloads for disaster recovery from that perspective. So again, I said it earlier, we don't have to repeat it, but the partner selection was critical for us. I will talk a little bit at the end. I'll let Matt get into the technical details here about the relationship that we have built with Zerto, how we did that in the beginning, and then how we've continued to mature that going forward. And from my perspective, it's been a phenomenal partnership to date. So with that, I'm going to turn that over to Matt, and then he can start going through the technical details of the implementation. He's got a couple areas he wants to talk to.
Okay, my name's Matt Braga. I'm a cloud system architect for Kronos. I've been there for about 3 years. Very glad you guys have all given us your time on the last day here. I've been let's see, I've worked on many projects, many implementation designs, many implementation projects at Kronos. Without a doubt, in my 3 years there, the Zerto project, what we did implementing this product, designing the product, putting it in place, this probably was the most satisfying. I mean, for me, this moved the business needle for what we were able to provide to the business exponentially. I mean, this was the most bang for the buck out of everything that I've worked on in the last 3 years. So I'm really, really glad you guys are here to listen to our story, right, and what we went through. I saw a show of hands. It looked like some people are evaluating the product, so hopefully you got some good information while you were here over the last 2 days. Hopefully you've increased your comfort level with how the product works. And it occurred to me when I was putting the slides together, it was a little over a year ago that myself, Scott Hinault, a lot of our other architects, network architects, storage architects, we got a pretty big team, right? We were sitting in a room. We had been through the POC. We loved what we saw. You know, that HTML5 portal, right, that shows you sub 60 second, maybe it's sub 10 second, whatever it is, that roll-up that it shows you in the ZVM, how awesome that was, right? And, you know, we're a VMware shop. We're coming from a very popular VMware array-based replication product, fill in the blank. So we loved the product in the POC. And when we went to sell this, and we said, look, this is so awesome the way that it works. If we're not going to look at the potential of doing this at scale and looking at this as being our real solution for everybody, then we're not doing our jobs right. So we presented this up to Scott. Scott went up above his head to the people who make the decisions, right? And the big question we had that we had to prove was, how are we going to know, how are we going to be certain that what we're seeing in this lab, this POC, 10, 20 VMs, of course it runs great. How are we going to be sure that when we go to 1,000, we have a pod architecture, so we have multiple pods, each of them could have 1,000 and 1,500 VMs in them. How are we going to make sure that we still see that beautiful green HTML5 roll-up that's so welcoming? It just makes you feel like you're doing your job right, right? So up here, this is the pinnacle of my graphic abilities, is stealing JPEGs off the internet and throwing it on here. But, you know, I had tried to find a white Testarossa. I had a white Testarossa up here, Miami Vice, you know, Tubbs, Crockett. But Zerto Red, I went with the Magnum PI. I replaced it just for this. So, you know, this is how I've described it to people internally at Kronos, is look, we've moved from having all our workloads on an array-based asynchronous snapshot schedule, right? It's kind of happening in the background. If it doesn't complete in the window that it's supposed to, you may hear about it from your storage team. You may not, but it's kind of just happening in the background. You don't really have any insight into what's going on with the individual workloads, with your individual customers. You know, with this product, we've moved to 6,000 Ferraris. Absolutely. Every workload has its own journal. Every workload has its own RPO rolled up to the VPG. And the reporting we get with the product, anyone can go in there into that portal. They can sort by RPO, and they can see exactly what's happening, right? So 6,000 finely tuned Ferraris. So again, the question we had was, works great in the lab. We want it for everybody. We were very, very impressed with the product, as was our director leadership. But the questions to ask, and these are the three, we don't have a lot of time. I had to peel out a lot of the things we wanted to talk about. So I boil it down to three areas of interest, right, that we had to solve for ourselves. We had to ask for ourselves and get together as a team, kind of figure out how are we going to address these three areas. So I picked the top three. Hopefully they relate to what you're interested in hearing about. Oh, and by the way, this is about you guys. If there's any questions at all, feel free to raise, interrupt. You don't have to wait to the end. So the first thing we had to ask was, how do we ensure our highways are big enough for all these Ferraris, right? When we follow the I/O of what's happening, you know, when you play follow the I/O through Zerto, there's a lot of choke points in your infrastructure from when the VRA grabs it. And there's nothing cooler, right, than the way they've architected this product. We've got the VRA that has that plug-in to the ESXi's storage sublayer, and it's seeing the writes as they're coming through. It's grabbing them, it's coalescing them, it's compressing them, and it's sending them out to your DR site on the wire before the writes even hit your storage fabric, right? I mean, it's beautiful the way it's architected. So, but there's a lot of choke points in your infrastructure, right? Whether it be compute, networking, storage. There's a lot of things you need to think about to ensure that your Ferraris aren't going to get congested when they get over to where they need to park, right, at your DR site. Number two, how do you safely onboard existing production workloads? So Kronos is very conservative when it comes to our customers. We have, I'll say the word, Scott, you may disagree, but we have a militant change control board, right? Where if we try to do anything, you know, I can't tell you how many times I've been kicked back to 2 or 3 cab meetings to try to make sure that we've covered all the bases, that what we're going to do, whatever it is, isn't going to adversely affect the customer with added contention, whatever it can be. They seem to be all over us. So, you know, how do you get 6,000 VMs into this product safely? And how do you do it relatively quickly and consistently? I mean, these are all questions that we had to answer to make sure that we can do this at scale. And then the third question we're going to go over in this presentation, so you've got your highways laid out. That's awesome. You're comfortable that your Ferraris are not going to be held up on any choke point from point A to point B to your DR site. You've got them all onboarded, you know, brownfield implementation. Everyone's in. This is awesome. But at the end of the day, how do I report back to Scott and the other directors on the team that, hey, the beautiful RPO that you see up there, that HTML5 portal, I keep going back to it, that's true. I'm going to put my job on that and say, look, I'm going to go, what it's saying it can do, what it's showing here is 100%, like I'm going to stand up and say, yes, we've tested this, and we're 100% certain in that nuclear moment, it's going to perform, right? So first, lay the groundwork for some discussion. I pulled out a lot of slides because I had to cut it down. I had a lot of information about us, but I shrunk it down just to one because I wanted it to be more about questions that might relate that you might want to ask for your environments. So if there are any more detailed questions that you guys want to know about how we did things and our logical design, anything like that, ask. We've got a whiteboard here. I'll happily draw anything up. But about us, quick facts. We're a vSphere shop. Quick show of hands, how many people who have implemented Zerto or vSphere? And Hyper-V? Okay. So this will translate well, what we've been through. So we're 100% vSphere. We got about 760 ESXi hosts. This is across our production and our non-production DR site. We've got a pretty large storage footprint. I counted up last week getting ready for this. We actually have 27 three-part arrays. Worked with my storage guy to get that number. I had no idea it was that high at this point. And we've got currently 5,700 virtual machines under protection today in 5.0 Update 2. We just upgraded last week, actually. It was pretty painless. And the 5,700 virtual machines, collectively, it's about just south of 2.5 petabytes of thick provisioned VMDK that we have under protection. That's about all I have to say about our hosting environment. Okay, so of the three questions we're going to talk about, first, infrastructure highways. So if you played with it in the lab, or you've got a small production implementation, you know that the way that the product scales, you have one VRA per host, scales out horizontally, very, very intuitive the way it works. And when we went through our POC, we were very certain that, yes, we understand how it works, it's intuitive. As long as we scale things out horizontally with the workloads, we had no real qualms we had no real concerns that it couldn't do what we saw in the lab at a greater scale, right? We were fairly certain of this. But the question came down to, you know, the tripod of infrastructure. When we play follow that I/O from side A, from our production source, over to side B, the DR side, you know, we need to make sure that all of these highways are wide enough for the 6,000 Ferraris to not get held up at any point. And when I talk about how we size to peak. Scott mentioned our application is essentially it's workforce management, right? It's payroll. So it presents a very interesting sizing challenge for us in as much that everybody runs payroll at the end of the month. Everybody runs at the end of the quarter. They all run it at the same time. So if you can think about what that means for us, it means that you might have pretty quiet systems throughout, I don't know, 80% of the work week or the work month. And then everybody uses their systems at the exact same time. And they all have to perform. So one of the joys working with Kronos actually is that we're told consistently size to peak, size to peak, size to peak. I've never worked at a place that tells you that. Usually they're saying like, how much contention can we do? How much contention we can do? How much contention can we do? Save money, save money, save money. So it's fun to work at a place that says size to peak. The customer cannot have contention. But this translates back to how we size for Zerto. So there's RPO and RTO that the customer is sold. For us internally, we knew that we could beat the pants off of any RPO that we were going to sell. So for us, we were sizing to peak. We wanted to ensure that when we went from the lab to 1,000 VMs, we could have that sub 60-second RPO, right, throughout the US business work week. So we sized our highways to peak. Not everybody needs to do that. If you're okay going to a 1-hour RPO, it's fine. Your Ferraris can get held up, whether that's at the network layer, the storage layer, wherever it is, that might be acceptable for your business requirements, right? So number one, who likes networking? Right? So networking, I respect network guys. I'm fortunate enough to have 2 network architects that I work with. They're both out of Canada. They're great guys. I'm a bit of a jack of all trades. My take is that networking is the hardest of the tripod there. It's fantastically complex, or at least it can be. So since I've got those guys who do most of the networking for me, I've got one slide on networking, and it's that onion. That's about all. That's my one slide on networking. But when we think about what I'm trying to say here, figuring out your highways for the 6,000 Ferraris, or however many Ferraris you want to run in your infrastructure, right? It really comes down to determining your workload peak. And most of the time we spent, we had a lot of arguing internally on the team about this. It was mostly around, all right, we can see what our workload creates as far as bandwidth on the write bandwidth, right, and write IOPS on our source array. And we can extrapolate that out to what that's going to mean needs to go peak bandwidth, right, when all of the writes happen. And we're talking about writes with this product, clearly. We're replicating the writes, right? We determined what that was. The big question for us, though, was when we go north to the, when the VRA compresses it, native compression is on, and then when we go north to our silver peaks, which further optimize our network traffic, what are we ultimately going to need to send across the WAN? And there was a lot of discussion about this, read a lot of work papers. We talked, our sales team, we talked to them endlessly about white papers and their experience with other customers using riverbeds, silver peaks, what have you. But at the end of the day, I urge you, you're going to have to figure it out for yourself for your own workload. Right? When you think about the write activity of a workload and how variable it can be, as that gets thrown up against an algorithm that's kind of, the compression algorithm within the VRA, and it's variable, you can't read a white paper. You're going to have to take the time. I urge you to take the time to figure out what your workload is going to look like going through that VRA and what compression you're actually going to see. Right? For people who have Zerto installed, how many people have the native VRA compression turned on? Probably everybody? Yeah. I don't see why you'd turn it off unless you were CPU bound or something. I don't know. I don't know why you'd ever have it off. In any event, what we saw was, we saw about 50% compression out of the VRA with native compression. I think that's what the marketing slide said. And out of all of our testing, it ended up being about 50%, which is kind of funny. So we had 50%, figuring out number 4 there, right? Our core workload. What is our workload? A single instance of our workload really going to consume after it goes north through the VRA, 50%. Then it goes up to the silver peak, right? We actually saw another 60% optimization on top of that compressed traffic with the silver peaks, which was completely not expected, even by our network guys who actually know how the silver peaks algorithms work and how all that magic happens. I don't think anyone expected that. But at the end of the day, sizing your network, it's about aggregation. Once you get that, once you understand what a single instance of your workload is going to look like, and what it's going to get going through this, whatever compression algorithm you're using, whether you have Riverbed, Silver Peak, maybe you don't have anything at all, whatever you have in your environment, then it's about aggregating it out to all your choke points, right? So for us, we then took, all right, what's our density of workloads at the host level? Okay, how do we get all that VRA traffic out of the host in a manner that is not going to introduce any contention to the customer? And for us, that meant, okay, we got a new distributed switch, some new flex NICs. We've now got a physical separation of this VRA traffic coming out of the host. So it's not going to mingle with the customer traffic. There's going to be zero contention. From there, we went up to our chassis. How do we get this out of the chassis safely? Well, we ended up building a new distribution out-of-band network, completely bypassing our top of rack where all the customer traffic would go, right? And then go up through the customer layer 7 firewall. We decided, look, there can be no contention, so we created a complete out-of-band network. And then we just built out our layers of the onion, right, where we're aggregating up how many workloads per host, how many hosts are in the chassis, fantastic. How many chassis are going to link up to the distribution network? And ultimately, when you get to the last distribution and we get to the last layer of the onion, eventually it all comes up into our various Silver Peak pairs and needs to go over one of 2 10 gigabit WAN links, right? So it was just basic, very simple math. I'd say the hardest part of the whole thing was in the lab and getting a very good comfort level about really what were we going to see with gains, right, with our workload through the various compression algorithms. Yes, sir. Yeah, so I mean, the array is obviously not going to go through a VRA, so we're not going to be picking up compression. I think you guys use it. Yeah, so it is different because so our array-based technology is asynchronous, and it could be every 2 hours, every 4 hours, whatever we had sold for an RPO. You could have the same bit get changed, 100 times over the 2 hours, but at the end of it, the delta is the 1 bit. With Zerto, since it's happening in real time, if that bit gets changed 100 times, it's going to go over the wire 100 times. So it is different from that standpoint. It's a cost of the way that they do things, right? Having that, it's happening synchronously, effectively, or near synchronously. Okay, so all I got to say about network storage, there's going to be 2 questions here. We're going to talk about utilization. How do you figure out how much space you might actually need for your 6,000 Ferraris to park when they get over their highways at the end? Then we'll talk about performance with storage. So determine your journal history requirements. This is probably the main thing that you're going to have to do. Let's see what I put up here. So determining your journal history requirements, it depends on what you want to do with it. We went live with 4.5 Update 3. I think it was either a week or maybe 14-day max journal at the time. And you can do a 30-day journal, I think. If that's anyone from Zerto in the room, I think it's 30 days now with 5.0 Update 2, where we are, or Update 3, or whatever the latest is. So depending on your business requirements, that opens up a lot of potential for backup, a whole bunch of cool things you can do with a large journal. For us, our business requirement was always strictly DR. Now that might change over the next year. We're talking about more interesting ways to consume the multi-target capability now with the product. But when we went live last year, it was all about DR. It was all about, we don't really care about having this massive journal. It'd be cool, right? But it's going to cost, it's going to cost disk space. We're going to have to accommodate a very large journal, and the way that our application writes our SQL servers, that if we want to keep a 30-day journal, I can tell you right now it's going to be very large. But again, back to our original requirements, it's just simply get the VM up as quickly as possible and make it as performant as possible. And anything that's going to get in the way of that, let's not look at it. So it's a bit of a trade-off with your journal, right? When you're sizing your journal, when you think about what needs to happen, the larger the journal is, it could potentially affect your RTO. Because if I've just got a 1-hour journal, I hit the big red button, all my VMs come up. What the VRA has to do, the VRA actually has a lot of work to do. It has to take your journal checkpoint, it has to uncompress all of the information in the journal that's south of that, and has to write it back to the recovery volume. And while it's doing that, it also needs to provision a scratch volume, so any new writes coming into the VM that's being promoted, they can actually be absorbed and you can use it. Very, very intensive operation for the VRA, and your VM can't move. DRS can't relocate the VM while it's doing this, right? So your performance is certainly a bit hamstrung, I guess if that's a word, while you're in the promotion phase. So for us, it was, no, we want to get through that as quickly as possible. We don't want a very large journal potentially with a lot of writes, maybe they have to get uncompressed and then written back to the recovery volume in that nuclear moment. We want it to be as quickly as possible. So something to think about with a large journal, it's a bit of a trade-off. It can be a trade-off. So for us, it was, hey, 60 gigabyte hard limit on the journal file. And it became pretty straight math at that point. To walk through to walk through the requirements there, number of protected workloads in one of our pods. Each one is going to consume a 60 gigabyte journal. I've got a ×2 there because I talked about the scratch volume. When you're actually promoting and committing a journal checkpoint, it's being written back. The VRA will then provision another disk called the scratch volume, which is by default the same size. I don't think you're able to change that. I think it is set to be the size of your journal file. So for us, it was pretty easy. We're looking at what's then provisioned on the source array. Fantastic. We know that we're going to have to replicate those recovery volumes over there. Really, the delta is about your journal and your scratch file to figure out how much space you're going to need so all your Ferraris can park nicely and not get dinged up, right? So performance, I tried to throw something up here. We read a lot of white papers and asked a lot of questions about this. I'm not going to say too much about it other than you got to think about what really happens, right? What the VRA needs to do to get a write that it sees in that ESXi storage sublayer. what it really needs to do with that, and what happens over on your DR side. When we think about what happens, if there's 1,000, let's say there's a burst of write activity at 1,000 write IOPS. So the Zerto is going to see that. That's the VRA. The VRA sees that going through the ESXi's storage sublayer, sees the 1,000 IOPS, assuming a 50% compression ratio. Let's say that it, for simplicity of the conversation, let's say that it shrinks it down to 500 IOPS. So the 500 IOPS come over to the VRA on the destination side. VRA gets it. It says, OK, fantastic. I've got some compressed IOPS here. It's going to write it to the journal. And then the next thing that will happen, right, in the life of following this I/O, at the end of your journal window, the VRA has to grab those 500 IOPS, has to read them back, has to uncompress them, and then it has to write back the full 1,000 to the recovery volume. So I think this is correct. What you end up having is 1,000 write IOPS on your source array ends up looking something like this. So when you're thinking about choke points on the storage sublayer, the DR array has to be pretty powerful. Read IOPS happening on your source array obviously don't come into it. It's all about writes. But at the end of the day, we use this model to really figure out, our storage guys, OK, how performant does a DR array actually need to be in order to make sure that this isn't the choke point that affects our RPOs and has it go north of 60 seconds, which is our internal goal as an infrastructure team. What was that? They're on, so the 3PAR, the way that it works, they're on the same set of spindles, but they're on different data stores. So, and we made the design decision to do that. The reason why, so the 3PARs can do what's called a live LUN migration. So the fact that the journals were all on one set of LUNs and one set of data stores, if we got to the point where, look, the write activity happening with this nonstop write and flush, it's actually, our array's having issues with it. Our storage team had the ability to just live migrate to dedicated SSD. And so that's why, so they're on the same array, same spindles, but they're logically separate. Yep. Highways compute, how are we doing for time?
50.
11 minutes. OK, let me speed it up a little bit. Highways compute, I don't have a lot to say about here. The standard for VRAs in 4.5 Update 3 was 3 gig RAM and 1 CPU, I think, is what you get out of the box. We were advised by the professional services team. We worked with at Zerto. They looked at kind of what our workload was doing for writes, and they highly recommended that we double the RAM to increase the buffer so that we can avoid bitmap syncs, right? I'll say that that's kind of what we went live with. We doubled the 1 to 2, and I think that's a general best practice if you have the VRA compression on. You want that extra core. Doubling the RAM is, we went live with that. We're in the process now as we operationalize this. We're increasing that actually as needed, right? We found that some of our really large customers, bursts of I/O, that gets blown out. We bitmap sync, and we might go from 60 seconds to 5 minutes. So we're tweaking that right now, and I would say that's the minimum that we're doing would be 6 gig. But we've gone to 9. I think 16 might be the max. We certainly haven't gotten up to that, but that's something we're working with.
You have a question behind.
Sorry? Correct. Correct, both. 17 to 20. 17 to 20, I'd say, VM density. The VRA's got to work harder. Yep, and that's an important point. I mean, as hardware advances, right, microarchitecture, cores get more dense. Every generation of blades seems they can fit more on it. It's great. We want to put more workloads on there to get more bang for the buck with our ESXi licensing. But something to think about, you're right. The way that this product scales out architecturally, it's only one VRA on that host. So generally, you need more workloads, you add more hosts, you get more VRAs, it scales nicely. But you made up an excellent point. I mean, I don't know, 10 years from now, let's say we have 200 physical cores in a blade. I mean, I'm sure that Zerto will figure it out and change the way they do it.
Without the additional investment, you're only compromising the time on the RPO. And at this point in time,
Correct.
Looking if we stay, it goes from 60 seconds to 5 minutes.
Correct. It's still completely acceptable. Talking about array base where RPO 4 hours, 8 hours, or whatever you're doing, I mean, it still beats the pants off of anything else in the marketplace that we looked at. The one thing I'll say about compute, so we know that it scales out horizontally with hosts. It's great the way it's architected. We're going to talk about what we did for testing. We did find when we did our testing that we had to dramatically size up the recovery side ZVM and vCenter. And when we think about what needs to happen, our at-scale test was 1,000 VMs, like hit the nuclear button, 400 VPGs, 1,000 VMs, go. What it does is EVM queues it all up and it starts sending commands and events, asking actions for vCenter. The first test we did, vCenter was sized to probably a third of that, ZVM the same. I mean, it was clearly the bottleneck. CPU pegged 100%, active memory pages on both those VMs was like 90%. So we ended up sizing up our recovery side, vCenter and ZVM, to what's on the board there. And it was no longer the bottleneck when we went forward with additional tests. That's what we ended up with, right? Okay, so we've answered the first question. Sizing your highways, your Ferraris, they've got enough runway to go. Hopefully that you've got no bottlenecks in. You're looking good to keep your RPO close to what you saw in the lab. Onboarding workloads. So Kronos, again, very, very, very protective of their customers. We really like our customers. When it came to onboarding the workloads, there were two things, and we're going to talk about two things in this section. Consistency, how at scale do you make sure that all your VPGs are created with the same settings? And then back to our concern about the customer, contention, right? So how do we get 5,700 VMs on and onboarded into the product in a manner that's safe, right, for our brownfield implementation? And it's like a tree falling in the woods, right? We want to get all this VMDK read and onboarded into the system so that Zerto can start grabbing those IOs at the, above the storage area network. But how do we get it onboarded safely? So for consistency, we went live last summer. 4.5 Update 3 had just come out. Anyone from Zerto, correct me, I think that the majority of the really useful API settings that actually allowed you to create a VPG with all the settings you care about came out in 4.5. So for us, the timing was perfect. We could not have done what we needed to do from an automation standpoint at our scale prior to 4.5 Update 3. I'm not going to say a whole lot about this. There's a vibrant community out there. Did anyone go to any of the API sessions over the last 2 days? There's a great one today in room 310. I'll say that at scale, no matter how good your process is, and no matter how good your operations team is, they may be awesome. Doing 5,700 VMs through a checklist, there's absolutely going to be inconsistencies. So the RESTful APIs are going to be your friend. We actually had a very polished script handed to us by professional services, and we kind of took that and wrote wrapper scripts and did all sorts of stuff with that to consume it. That's just a real quick selection box that was from our onboarding system that the L1, L2s were able to use. But the APIs are going to be your friend at scale. You absolutely have to get comfortable with consuming them. All right, contention. We all know that Zerto doesn't touch your source array. We talked about the awesomeness of how it grabs them in flight before it even hits the fabric, except for these two times, right? The init syncs and the delta syncs. So back to our love for the customer, how do we get them onboarded and make sure that it's like a tree falling in the woods? They just get onboarded. I don't have Scott Hinault standing over my cubicle on a Tuesday saying, why am I getting the operations team saying we're having Sev1 outages sporadically, right? And we want to do it, we don't want our array to look like that. I mean, it can be, when you think about what needs to happen if you were to onboard 1,000 VMs at once, it could be a lot of read activity that would need to happen for the system to read all those blocks in at once. Because that's what happens, right? When you onboard a customer, the VRA needs to read every single block on all that VMDK in order to send it that first time, right? That's the cost of initializing a workload into the product. So what we did, we spent a lot of time arguing about this and worrying about this, a lot of time worrying about this, a lot of cab meetings saying, are you guys sure? Are you guys sure? Are you guys sure? What ended up happening was we took a very metered approach, and working with Zerto Professional Services, they explained very, very clearly what their native throttling algorithm is in the VRA and how it works. And it was very, very effective. Each VRA, you have to understand, has an internal throttling mechanism. It's never going to read more than 72 or process more than 72 concurrent read IOPS at any given time. So what that means is if you queue up hundreds and hundreds of VMs, across a set amount of VRAs, no matter how many you've queued up, the VRA is only ever going to push concurrently no more than 72 read IOs while it's doing its init sync. So with this knowledge, we'd come back to our storage guys and said, okay, let's say we have 4 clusters in a pod, and each cluster is 16 hosts. So that's 16 VRAs, right, in each cluster. If we take a metered approach and we write our API wrapper script to look at all of the VMs in a cluster and then present only that cluster's VMs up to our operations team. And so they're in that GUI and they're selecting whatever they want to select. But because we're consuming the APIs in the manner that we are, we're able to guarantee that for week 1, and we did this by week, we're able to tell our storage guy we're never going to have more than 16 hosts in a single cluster. 16 VRAs are going to be in the game of reading read IOPS off the disk to init sync something. So it ended up being about 1,200 read IOPS. If your array can handle that, it's like a drop in the woods, a tree falling in the woods. Nobody knows that it happened. You're going to be okay, and this is exactly what happened to us. After all the worrying, the native throttling in the VRA is very, very effective. We had a very advanced VROPS dashboard. We had people looking at it during the entire onboarding process. We never really saw a spike in latency. I mean, our 3 pars are pretty wide. There's a lot of spindles, but it went flawlessly because we took this metered approach. So week 1, we did 1 cluster. Weekend, everyone took a break. Actually, we tested on the weekends. We'll go into that in the next slide. Week 2, week 3, week 4. So we took this approach across all of our pods, striped across, and we got our 5,700 workloads onboarded in about a month. It was about a week per cluster. We controlled it with the metered approach. It was like it never happened. It worked out very, very, very well. So when you communicate that to how it works to your storage guy, they're going to say, oh my God, they'll start sweating bullets and say, whatever you do, don't throw 1,200 read IOPS at the array. It's going to tip it over. Or they're going to say, not a problem, throw it on. So finally, last part, we talked about the highways. We talked about onboarding. So the last part is, okay, great, the highways, they're set up. We've got that architected and implemented. We got our 5,700 VMs, the Ferraris, they're screaming across the highways. It's all awesome. How do we actually test and be sure that what we're seeing in the portal and what I tell the directors and Scott we can do, right, when that nuclear button happens, how do we make sure that it's actually going to perform and come up and, the RPO of 60 seconds is really there, right? We took a metered approach. Let me go back a couple slides to here. At the end of each week, so we did cluster 1. That's about 25% of our workloads in a pod. At the end of that week, on the weekends, we actually did a non-disruptive recovery test with the product. And we wanted to spot check and just make sure that VMware tools came up on all of the boxes. That would mean that there wasn't a boot issue. It started up, services started up. We did some spot checking with our DBAs. They went in, they ran some consistency checks just to make sure that the SQL Server, everything was good. So we slowly built confidence with this product throughout our implementation period, where on that first weekend, 25%, great. It came up within, I don't know, a couple hours or something. Week 2, 50%, it was very, very linear, right? Everything came up. But what we did throughout the entire onboarding process was build confidence with the product. So then when we got to the end and did a pod scale recovery, which was for us was that was really the make or break. That's what we had to sell, right, to the implementation team or the people grading our implementation to show that it really worked. We created a test plan around failing over an entire pod. So we built up confidence so at the end we didn't just try it and then be unpleasantly surprised. Oh, 500 of the 1,000 didn't boot and there's corruption. They didn't get inflated properly. There's something wrong with Zerto. We did not see that. So the nuclear moment implementation test, I already talked, our project conclusion was a full test. We did 1,000 VMs, 375 VPGs in our test. And at the end, we ran it about a dozen or so times just to make sure that it wasn't a fluke, that whatever we reported back for an RTO, that what the product could do, we were very, very confident that yes, internally, every time we do this, every time, we're very, very confident that if we stripe this across all of our pods and they're all happening at once concurrently, that we can get the entire environment up in what we've emulated in a single pod. Yes, sir.
So with that size of the pod, are you using the built-in database on the CPM?
No, we're a SQL Server shop, so our DBAs are very, very, very comfortable with SQL Server, so we're using external SQL Server for the ZVM.
So can you talk about where is that SQL Server database located at to be able to scale it over? Is it
Oh, that's on, so these are customer pods, customer workloads. Those are on like a management cluster. So they don't exist in the customer pods. We have specific pods that run just customer workloads, and that's what's under protection with Zerto.
so SQL's outside of
Correct. Both the ZVM, the external SQL server, that's not within the pod that's being replicated. It's under management. Say that again? We did not. No. Great question. So we had that discussion. Do we want to manage VSS schedule right at this scale? We did a lot of testing around crash consistency. If you remember, I talked about as we built confidence with the failovers, we were doing consistency checks all the time. These are just crash consistent, no VSS quiescence. And we did hundreds. We didn't have a single crash consistency check failure. And I know on the industry, they generally say you're so unlikely to see that today with SQL Server. Most people will say don't worry about it. We tested it a ton. We never saw an issue. So we do not do VSS quiescence. But we're comfortable with the testing we did. We're very comfortable. We don't need to worry about it. If the 1% chance, maybe it's a 0.001, whatever that chance is, there's going to be some corruption. We accept that as, if we have to go to VTL to restore one of these on the other side, 1 out of 1,000 or something, that's acceptable for us. And that's it. That's really the end of my presentation. There's the Ferraris going across the highway really, really fast. They're all red. They're Zerto. And that's those are 3 high areas. We couldn't get into it too deep, but that's how we approach 3 of the most important questions for doing this at scale. Yes? 40 to 50. Yep, so 40 to 50. And there might be 1 or 2 in there that are SQL Server, that are really high write I/O. The rest of them will be a lot of application servers, so not as high write I/O, but I'd say 40 to 50. And they can be as small as 1 or 2. And the ones that are 40 or 50 are few and far between. Yep.
Can you talk at a high level about the kind of network setup as far as do you have layer 2 stretch across the primary?
No, we have, so we provisioned an out-of-band network coming out of each of our pods. So a pod may have a number of chassis. We provisioned fresh uplinks out of the chassis going, so let me take a step back. Prior to Zerto, the only Ethernet egress point out of one of our pods was through the customer top-of-rack switch and through a customer-facing layer 7 firewall. So we determined very early on, our network guys did, they said, no, you're not going to throw this kind of bandwidth through the layer 7 firewall, which is completely understandable. So we had decided, look, we're going to have to, again, we love our customers, zero contention. We have to do this so there can absolutely be no effect on the customer experience. So the uplinks, we created a new out-of-band distribution network, burned uplinks directly out of the chassis to this distribution network, and then from there, they route directly to Silver Peak pairs. So the way that we actually did it, we have many, many pods. I think we take pods in pairs of 2. So you might have 2 pods will end up going through a distribution network. The VRA traffic will route through a distribution network, and they'll get picked up by a pair of 2 VX9000 Silver Peaks virtual appliances. And they're active-active. If one of them fails, it'll pick up the traffic for the sister pod, and vice versa. They're kind of meshed like that. And then the Silver Peaks face an external switch. We have 2 10 gigabit WAN links, diverse physical paths to diverse carriers. And that covered. We got a lot of room for growth too. I mean, the Silver Peaks, I'm not a network guy, but God, I don't know how they do it. Those things are just nuts with the savings they do. It's like magic to me.
So that's for the replication traffic. So I'm talking about when you configure the test recovery networks.
Oh, sure. I got you. I'm clear with what you're asking. No, so we don't touch the customer workload. We don't change IPs. There's no stretched L2. But what we have is, the routes become active. There's different OSPF communities, one on the source side, one on the destination side. So when we hit the button, they come over on the other side. They come up into a port group, right, a layer 2 port group, named the exact same way, same VLAN. So the layer 7 firewall that's over here, it's got the same configuration as replicated, obviously not with Zerto. We have another tool that the network team uses to replicate the production layer 7 firewall configuration to the DR side. So when those come up over there, the DR layer 7 firewall already has the layer 3 configuration, the layer 7 firewall rules. It's already in place. So they just kind of come up into an environment where they can work, they can get through the top of rack, and they can plumb out on our DR side. So we don't change the workloads. You can do a lot with the recovery plan, right? You can re-IP, you can run a PowerShell script, you can run Bash script, so that basically means you can do anything you want, right? The world's your oyster with what you can do with that. We made a determination very early on, it's do not touch the workload, just introduces too many variations. So we don't change the IP.
We're kind of in the same boat. We used to have to change IPs and change server names, and that was a nightmare.
Yeah.
Now with Void and Crypto, we're kind of the same boat. We don't want to have to change any
Oh, it's
configuration. So test network, like you said, we've got the same VLAN configurations on the test side, or we keep it isolated for a test, and we're trying to figure out what can we allow in the test,
yeah,
what can we not allow in the test, and how that will become a true disaster.
right.
So that's what we're trying to figure out how many holes we can poke in that test model.
Sure.
I mean, we struggle with the same thing, right?
Yeah, we're in the process of advancing our DR testing scenario, and it's a work in progress as well. It's a tough problem to solve.
Yeah.
You have Active Directory. We have one Active Directory for both. Can't break the replication of AD if the same object comes up. It's a tough problem to solve. Yeah.
I have a question.
Yes.
So I don't want to push you on the actual RTO because I appreciate you probably don't want to share that given your line of business, and that's why
Yeah.
it's on the slide. But my question is did you look at changing any of the advanced tweaks
Great question.
to drive the concurrency faster?
Yes, that's a fantastic question. I meant to talk about it, and it slipped my mind, actually. By the way, it's 210, so just so everyone knows. We did not change any of those advanced settings. What we did find with our RTO, and I'll say this, we were very concerned about bottlenecks with bringing up machines. Zerto, fantastic. It's fantastic at RPO. RTO, I'm not saying it's worse than other competing products at RTO, but RTO is not really what it focuses on. It focuses on that sub 60 second. That's what it's architected to do. What we found was the bottlenecks I talked about, the recovery side ZVM, the recovery side vCenter. We figured that out on the first test that we did where we just did the first cluster, 25%. That was very, very obvious. We sized that up. I was expecting with the storage guys that we're going to see, when you reconstitute a VM with this product, it's an intensive process on your array. There's a lot going on. I was certain we were going to see like latency and just tons of I/O on the DR array. We didn't. What ended up being the bottleneck, and with RTO, is what you've said. It's the native algorithm. Algorithm is not the right word. The native throttling within the ZVM is only going to bring up, I think it's 10 VMs concurrently, or 30 VMDKs concurrently, and it's not going to bring up more than 5 VMs in 5 minutes on a host. Then when you think about it, if you've got a large database server that's got 10 VMDKs, and you've got a 300-second wait time before the next boot group starts up, this all starts to kind of queue up, right? So we didn't tweak any of those settings. We weren't afraid, but I'll say this, it came up within our agreed upon time, so we didn't need to go down that route. We asked professional services about it, and they said, look, these settings can be tweaked. They said, we recommend that you don't do that because what we've vetted in the lab, all the testing that we've done, is around the standards, around what's in there. Unless you have a really good reason and you talk to us, please don't do it. And so if we needed to speed it up, I'm sure that we could. But ultimately, our RTO, that's what bottlenecked us, was the internal scheduling, right, by the ZVM.
Well, I'll give you an interesting data point. I was doing Zerto certification on Nutanix.
Yeah.
And I found the default settings of the ZVM was not pushing the Nutanix fast enough.
Were you able to go faster?
I let it rip,
That's nuts. So you didn't see more timeouts at the vCenter, with the vCenter needing to process all the stuff concurrently?
With an adequately sized ZVM database
Yeah.
and vCenter, if the platform can take it.
Really? Any idea what your ZVM and vCenter was sized to? Was it anything like what I had up here?
Yeah, so it
Was this similar to that?
pretty, so it was
Yeah.
8 and 12, and then
Yeah.
6 for a dedicated database, and then the vCenter was
That's
32.
That's great information. I was in room 310 earlier, the API workshop, and I heard somebody in there say something similar, that they tweaked it and it got way better. So we didn't go down that route. We can. It might be something we do in the future if we decide we want to speed things up. But since we met our business requirements, we didn't. Yep. So that's all I had, Scott. I think you had one last slide here. Appreciate you. Any other questions? Appreciate you guys letting us go over.
Yeah,
Back to you, sir.
Thanks, Matt. So obviously you can tell, right, a lot of this from an execution and success and implementation is all of the planning. I feel like we don't have enough time, but I feel like I should probably take 2 minutes to try to get rid of the perception of a fire-breathing dragon manager that I am over Matt's shoulder, but I'm not going to waste anybody's time doing that. I just promise you that I'm really not that way. But you know, the bottom line here is, from a project perspective, or let me talk about from a Zerto perspective, from a company perspective and dealing with them, sitting with Paul in the negotiation and talking through that, they were really open to what we needed, what our business requirements were. They really listened. All of the things that you hear about, the buzzwords about what you expect out of your partners, and they were all of that. When I put up best vendor decision, I don't typically speak at conferences, and there's a reason from that. I don't want to get up unless I really believe in it. This was, and I've been doing this for a long time, as you can tell from the gray hair, this is the single best product decision that I've made in my technical career. So this product just flat out works. And as we went through all of the pushing, not only of the product through the implementation, but all of the process and project and testing, you know, the company was right there. They worked with us. They put up with us because, as Matt said, our customers really are first to us, and we'll do anything to make sure that we don't impact them in any way, shape, or form. So could we have actually pushed this and implemented this more quickly? We probably could have. But as an architect team, they came back and said, no, we're going to be very conservative in our approach here, in making sure that we do that. And the professional services at Zerto was there with us in helping us through that. And they understood why, and they understood our business and why we were taking that approach. So again, full partnership, and just a phenomenal partnership there in their support. We have now been live, I'm not sure exactly how long we've been live with the product in full production. So November, so almost 6 months, right? And we continue to expand our own environment, so the supportability has been tested, I would say, with them. And we've had, you know, minor issues that have come up, and when they've come up and we've brought them to them, they've come right back to us and been full support there, and brought a high level of caliber engineers to help us through the problem. So again, it's been great. So thank you for taking the time. I hope that this was helpful. Matt does a great job as always, so I know it was the most informative part. If you have any questions afterwards, we'll be happy to answer them. Thank you.